Hello, in this video, I'm going to demonstrate inheritance in Java. Let's create a project for the same. Let's create a class to work as a program. Consider a class called product. A product being an entity, let's put them in the entity package. And let's have some variables in that. Let's create a private int ID, private string name of the product, and a price for the product. We'll add a default constructor and then generate getter setters, and then probably a print function to print that. So we'll say here ID equals to ID, name is name of the product, and then price in probably let's put it in rupees plus price. So we can create here a product object P1 equals to new product. Equals to new product, and then we'll say P1 dot print. When I execute that, you can see we get ID equals to 0, name equals to null, and price equals to 0.0. That's quite obvious because we didn't initialize them with any values. Now, we can do that by using setters. We'll say p1.setID of 1, p1.setName of, let's say, for example, optical mouse. And then we can say p1.setPrice of, for example, 950 rupees. So execute, we get the output. Now, let's get rid of this. And let us say we want to create a class that is specific to one type of product with specific details about that, such as a television. Now, a television has an ID, a name, a price, but also has information specific to a television itself, such as what type of screen that we are going to use, or what is the length of the screen or the dimension of that, what is the pixel quality, and so on. Now, we can create another class with all these three and additional features, but however, Java is all about code reusability, so inheritance is a feature that helps us here. Let us create a class that is going to make use of this inheritance. Let us call it as television. Now, as you can see that there is something called superclass, and by default comes as object. Now, in the coding, we will not get that at all because even for the product, we had that object, but it doesn't show up here. However, we can change this television class superclass to, instead of object, we can make it to product. So let's go and say product. Now you can see that there is a small light bulb here that says content assist available. That means you can press control space. So I have PROD and then I can press control space, and you can see it gets the full qualified name. Now that I said okay, I have a class called television extends product. Now this is how you would say that my class television is a extension of a product with more features. Now what does it mean? A television is a product. Now that's the meaning of this. So if I go to the program 01, I can create a television object. So TV1 equals to new television. Now if you press TV1, you can see that, and a dot, and you can see that there are many methods, but they are also coming from some functions such as get ID, get name, get price, and so on. Now let's try printing that. You can see that there is no problem in tv.print, but I don't even have a function or not even a single line of code. And that's because a television class is a modified version of product. Of course, we have not done any modification at this point in time, but it is a modified version. So which means whatever is available in the product class is also available in the television class. So I can go back here, I can print this, you can see it says so and so. I'll type here TV1 dot set ID of 1, TV1 dot set name of, let's say for example Sony Bravio, and then I'll type TV1 dot set price of, let's say for example 95,000. And when I print this, I should be able to get that info. But which means the memory variables ID, name and the price for the TV are coming from the product class. So we can also add additional member variables. For example, I can have here what type of screen are we using. I can have here private string screen type, and then I can have here private probably int, probably you can say the size of the screen. You can also say screen size. You can also put a kind of a pixel rate and so on. Now I would like to limit to only these two for the sake of simplicity. We have a constructor. We'll also add getters and setters. Select both of them and say OK. So now that we have got more values, I can go back to program 01 and add those members also. I can say TV1.setScreen type is, let's say, LED, and then I can say TV1.setScreen size of, let's say for example 47 inch, and now I can print it. The problem here is that the print function is coming from the product, and in the product I cannot add additional variables because in the product.java we don't have a member variable called screen size or screen type. Now it is available in this particular class. So if I have to print, I have to write a function here called print or print info or something that prints the details of the product with these three, and then we actually print the details of the screen size and the screen type. So we can go and type here public void print, and you can see now that I get this information being printed. So I can go here and type here size or screen size equals to say screen size, and then I'll type here screen type equals to screen type. So it just tells me whether it is a LED, LCD and so on. Now when I print this, you can see that the print function is invoked on the television. The television has two print functions. One is defined inside that itself, and one is coming from the inherited product. Now all this time it was the inherited print function that was being called, but now the inherited print function is discarded or hidden, and the one defined in the subclass, that is television class, is being executed. But unfortunately it prints only few information than others. So what is the solution? So I can start printing each and every value, that is the name, ID and price, but alternately I can just make use of the print function available in the super class. However, this particular call will act as if it is a call to the same function, because it is always going to prefer to the local copy of the function than the one inherited, and this will cause a recursion, for example, or an endless loop. So when I execute this, you can see without even printing anything, it goes into the loop and then of course terminates by giving an exception that says stack overflow error, because each print function is calling its own print function. So we didn't mean to call that function, but we wanted to call the one that is defined in the product. So should I be creating a product object here? No. The current object itself is a product object. I can say this.print, which is again a call to the same function. I can also say super.print, so that we say, hey, do not call this function, call the one that is inherited from the superclass. So when I go back and execute, you can see that all information about the television is printed. We didn't even know that there is something called product class in this main function.